Hello everyone. Let us look into the first program of VLSI Design and Testing Lab. That is a experiment of a full adder where we are going to write a program for a full adder and we are going to simulate and check the result, and also we are going to check how much area is being occupied, how much power consumption takes place, and the timing details will be checked. So this is a program for a full adder. We are using the variables a, b and c. That is, a and b both contains 4-bit each. So it is added with the carry and two outputs are generated. One is a sum and the other one is the carry. So a, b, these are the two inputs, each containing 4 bits. It is declared as input, 3 down to 0, and one more input is required, that is a carry, and sum contains 4 bits, and along with the sum a carry will be generated which is stored in C4 variable. So here we have used structural level of coding. So what is the use of structural level coding? For example, what we are going to do here is we are going to write a program just once and we are using as many times as required. Here we are dealing with 4 bits, that is why we are using it 4 times. So now coming to the program for a full adder, all of us are aware of this syntax, module followed by the module name, and within the parenthesis we need to write the inputs as well as the outputs. A, B, C in are the inputs and outputs are C out and S. So here we are implementing the expression directly. So S is given by A XOR B XOR C in, and the expression for C out is being written here, that is A and B, which is ORed with C in ANDed with the A or B. So here you can see initially A, B with the initial carry is added and we get two outputs, one is a sum and the other one is the carry. The carry that is being generated will be given as an input to the next full adder. So that is A of 1, B of 1, C 1, and two outputs are generated, that is S of 1, C of 2, and this C2 will be given as an input to the next full adder. Same thing holds good here also. C3 is given as the input to the next full adder. And this is about the program for a full adder. Now how do we give the values to these variables A and B? For this we need to write a test bench code. So here speaking about the test bench code, so here you can see that A and B, they are declared as registers. Even C naught is declared as a register. Why it is being declared as a register? Because this A and B, it has to hold the data for some time duration. That is why it is declared as a register, and as soon as changes are made in A and B, it has to be reflected in S and C4. That is why it is declared as the wire. So we would have written this different test bench codes. So how do we actually connect our main program and the test bench code? In simple words, how do we say that this test bench is written for a full adder program? So you need to map it. So how it is being done? So you need to use the module name of the main program, then you have to map all the variables that are being used. Okay, so let us test the result for 3 different combination of inputs. It is given here A, B, C naught, and here hash 100. These are the time durations for which these inputs should exist. So next let us run the program, let us simulate it, and let us check the result. So follow the following steps. Open in terminal, invoke the C shell command, then you launch the simulator, select multiple step, then you need to select don't include any libraries, click OK. So first step is we need to simulate and check. Before simulation we need to compile and we need to check if the program is error free. So here first compile it. If there are any errors, it will be displayed here, and then the code has to be corrected. So both the main code as well as the test bench, it appears to be error free. Then you need to elaborate it. So elaborate the code next. Then you need to simulate and you need to check it. Let us simulate and let us see. Yes, and this is the result here. A and B are the two inputs. C naught initially it appears as 0. So the result is 6. F plus 3 plus 1. It is 3 with 1 carry. 9 plus 3, 12 plus 0. Okay, it appears as C. This is a simulated result. Okay, once this is done, next let us see the the various reports, how to generate it. So what you have to do is you need to write a RC script file, and then you need to run, and you have to check the area occupied, the power consumption. So let us see how to do it. For that you need to write the RC script file. You can see this is a RC script file. Okay, so we need to get the timing report, power consumption report, area report, the net list, as well as the gate level, like how much area is being occupied. All the information will be obtained here, and if required we need to give the constraints. We have to mention the constraints. So here you can see the constraint file that is being written. So what is the maximum delay at various ports, it is being mentioned over here. A, B, C naught, S and C4. Okay, these are the different variables what we have used in our code. So what we need to do next is open in terminal. Okay, you need to run the script file and you need to see. Let us look into the structure of a 4-bit adder. See here, you can see the 4-bit adder. So these are the inputs A and B, and one more input, that is carry, is being given here. So the output, the carry output is given to the next full adder, and the carry of this adder is given to the next one, so on, and finally you get the sum and the carry result here. Okay, now the various reports which are required is being generated here. You can see the timing report here, how much time is being taken to pass the input and to get the output. So the various delays, you find it here in this report. So here the power consumption report is being generated. So here see at various logic blocks what is the power consumption, it's given here. So area occupied, how much area is occupied in the chip, that information is provided here. I hope the explanation is clear to you. Thank you.